Assalamu alaikum. This is Talha bin Nadeem, and this is the third and possibly the last video lecture, recorded video lecture for the topic of engine emissions and their control systems. So I guess in the last video we started off with the hydrocarbon emissions from two-stroke engines. Then we studied the hydrocarbon emissions from CI engines, and after that we studied in quite some detail some of the emissions which are being generated during the combustion process in an IC engine. Those emissions are like carbon monoxide, oxides of nitrogen, photochemical smog, some particulates, aldehydes. We also discussed about the lead in the fuel which is being added to increase the octane number of a fuel. Then we also discussed the oxides of a sulfur as well, and after that we started off with the emission control system of the SI engines, and then we studied about and I explained earlier that we will discuss the modification in engine design and the treatment of exhaust gas products in quite some detail, but we will not discuss the modifications of fuels as we are more concerned with the IC engines, and we have already studied the modification in engine design and operating parameters in the last class. So in today's class we will basically discuss in quite some details regarding the treatment of exhaust gases which are being produced during the combustion process. So starting off with the emission control by exhaust gas oxidation. So here you can see that I have explained I have been explaining this for quite some time, that during the combustion some undesirable emissions are being generated in the form of an exhaust gas, and these exhaust gases consist of some undesirable gases like carbon monoxide, oxides of nitrogen, oxides of sulfurs, some and when we are talking about particularly the diesel engines, there are some soot formation and particulates as well which are being generated as a result of some incomplete combustion, and oxides of sulfur are being produced in the diesel engines as well. So some of these exhaust emissions are undesirable, and we do not want these emissions. We do not want to release directly these emissions into the atmosphere. Otherwise they have some very drastic effects on the environment and on the human health as well. So as I mentioned earlier, that after the combustion process ends, the exhaust gas which constitutes in the cylinder gas mixture that have been partially burned down continue to react during the expansion stroke, during exhaust blowdown, and into the exhaust process as well. Means if sometimes the reaction doesn't completely occur, therefore during the exhaust process and during the power strokes as well, reactions are still going on. So therefore over the 90 to 95% of the hydrocarbon emissions, means those hydrocarbons which are not which haven't combusted yet during the combustion process, they almost 90 to 95% of those hydrocarbon emissions usually react during this phenomena, either during the expansion stroke or maybe during the exhaust stroke, or maybe in the exhaust manifold as well. So carbon monoxide and small components of hydrocarbon. So during this condition, the carbon monoxide and small components of the hydrocarbon usually reacts with the oxygen to form carbon dioxide. And not only the carbon dioxide, since hydrocarbons contains hydrogen as well, so they will also form the water vapors as well. So therefore these undesirable emissions are being reduced, and for that purpose, for this after treatment purposes, some devices are being added, like thermal and catalytic converters, afterburners, exhaust gas recirculation systems, and the particulate traps. These particulate traps are only being employed, are only being incorporated in the CI engines, whereas these thermal converters or catalytic converters, afterburners, or gas recirculation, exhaust gas recirculation systems can be employed either in SI engines or in CI engines as well. So we will start off with the first device which is being commonly used, and that is of the thermal converters. So in thermal converters, secondary, as I mentioned earlier, that during the expansion stroke, or maybe in the exhaust stroke, or even after, when these exhaust gases have reached the into the exhaust manifold, in the exhaust manifold as well, there may be some reactions occurring which will convert the unburned some unburned hydrocarbons and carbon monoxides into the carbon dioxides and the water vapors. So thermal converters are usually being employed to increase these reactions, these secondary reactions. Means even after the combustion, if there are some undesirable products which are present in the exhaust gases, they will convert these undesirable exhaust gases into the desirable exhaust gases, like carbon dioxide and water vapors. Carbon dioxide is not as harmful as compared to the carbon monoxide, and water vapors are not harmful as well. So therefore these thermal converters usually enhances the secondary reactions, and these reactions usually require a quite high temperature. That is why this is called thermal converters, because at very high temperatures, the desirable reactions like conversion of the carbon monoxide into the carbon dioxide and conversion of unburned hydrocarbons into the carbon dioxide and water vapors will happen, but at higher temperatures. So some engines are equipped with thermal converters as means of for the purpose of lowering the emissions. So thermal converters are high temperature chambers through which the exhaust gas flows, and because of the presence of the higher temperatures, they will promote the oxidation of carbon monoxide and unburned hydrocarbons which is remained in the exhaust gases, and these carbon monoxides will be converted into the carbon dioxides, and if there are some unburned hydrocarbon, means those unburned hydrocarbons will also be converted into either carbon dioxide or into the water vapors. And for this reaction, the temperatures must be very high. The temperatures which usually these thermal converters are operating at around 700 degrees Celsius, 650 to 700 degree, or maybe above 700 degrees Celsius. So they require very high temperatures for these reactions to occur. So it is therefore necessary for a thermal converter to be effective that it should be operate at a very higher temperatures. So I am highlighting this point, that as the name suggests, thermal converter means they will be operating at a very higher temperatures. And what will be happening at that very high temperatures? The unburned hydrocarbons are converting into the carbon dioxide and water vapors, and carbon monoxide is being converted into the carbon dioxide. You will notice that these thermal converters are not treating the nitrogen oxides and sulfur oxides emissions. So this is the disadvantage of the thermal converters, that they can control the amount of the hydrocarbon and carbon monoxide emission, but they cannot control the amount of the NOx emissions. So because exhaust from the engines is often at lower temperature than is needed for efficient operation of the thermal converter, it is necessary to sustain the high temperature by reactions within the system. So again, it is a very good point that how this high temperature is being achieved. This high temperature is being achieved then when these unburned hydrocarbons and carbon monoxides are being converted into carbon dioxide and water vapors. As a result, large amount of the heat is also being generated. So because of this generation of the heat, higher temperatures are maintained, and we do not have to provide some additional energy. We do not have to provide some additional fuel for that purpose to sustain that higher temperatures. Higher temperatures are being achieved since these reactions are exothermic reactions. This combustion of the unburned hydrocarbon and conversion of carbon monoxide into the carbon dioxide is an exothermic reaction. Therefore, the large amount of the heat is being generated, and because of this generation of the heat, we are sustaining the higher temperatures inside the thermal converters. So as I mentioned earlier, that thermal converters control hydrocarbon emission and carbon monoxide emissions by oxidizing it. Means they will add the amount of the oxygen in it, but they cannot control the NOx emissions. And if our engine is operating at a very high flame temperatures, therefore some NOx emissions are present there, and in order to remove those NOx emissions, there must be some additional device for that purpose. But thermal converter is not offering that purpose, is not serving that purpose. And for such therefore, because of these limitations, instead of using the thermal converters, now the world has shifted towards the catalytic converters. And as the name suggests, that in these converters there must be some catalyst, and because of the presence of catalyst, the higher temperatures which were required in the thermal converters, the requirement of the higher temperatures have been reduced now. Means we do not usually require the temperatures like 600 to 700 degrees Celsius for the conversion of this carbon monoxide and unburned hydrocarbons into the carbon dioxide and water vapors. The temperatures were 600 degrees Celsius to 700 degrees Celsius which were desired in the thermal converters. But in the catalytic converters, since we have a catalyst present, these requirement of the temperatures have been reduced to 250 to 300 degrees Celsius. And this is the temperature of the exhaust gases. This is the temperature of the exhaust gases which we are basically getting from the engine exhaust, from the we can say from the exhaust valve from the exhaust manifold of our engine. So therefore we do not require very high temperatures. We do not have to rely on the amount of the energy which is being released when this carbon monoxide and unburned hydrocarbons are being converted into the carbon dioxide and water vapors. So all the disadvantages, all the limitations of the thermal converters are being overcome by the use of the catalytic converter. So as I mentioned earlier, that a catalyst would be used in these devices. And the purpose of the catalyst is to accelerate the chemical reactions. Therefore, the conversion of this carbon monoxide into the into the carbon dioxide, and the conversion of this unburned hydrocarbons into the water vapors would be occurring at very faster rates, and they would be requiring lower energies. They would be occurring at lower temperatures. So and the another limitation that of the thermal converter, that thermal converters do not convert the NOx's emissions into some desirable product. So this limitation has also been overcome here. And so not only these catalytic converters are converting this, are oxidizing these unburned hydrocarbons and carbon dioxide into the carbon dioxide, unburned hydrocarbons and carbon monoxide into the carbon dioxides and water vapors. They are also converting these nitrogen emissions, and they are reducing it. They are reducing it to form nitrogen molecules. So not only that they are reducing the they are oxidizing the unburned hydrocarbon and carbon monoxide, they are also reducing the NOx's emission as well. So all the limitations of the thermal converters are being removed, are being overcome by using the catalytic converters. So here you can see what are the basic requirements of the catalytic converters: that it should have a high surface area of a catalyst, and for that purpose, as we have studied in the intermediate level, that the rate of reaction increases when we increase the surface area. So when we increase the surface area of the catalyst, it will basically increase the reaction rates. And this is being achieved by using wire meshes. Usually meshes are being used for that purpose. Ceramic meshes are being used for that purpose. Another thing is good chemical stability, means our catalyst should not be reacting with the exhaust gases by itself. It should not react with it. It should be chemically stable. It should it should sustain its chemical state throughout the engine operation. And low volume heat capacity, it should have a low volume heat capacity to reach the operating temperatures. Means its heat capacity should be low, or it should not be able to absorb too much amount of the energy, so that the desirable reactions, desirable operating temperatures are being produced. And not only that, it should be chemically stable, but it should be physically durable as well. Means there should be any physical changes in the catalyst as well. Means it should not be easily it should not break easily, and it should not corrode easily, which is an example of its chemical stability. And last but not the least, that it should not provide it should have a minimum pressure drops as well. It should not be providing too much pressure drops, otherwise the problems of back pressure will occur. So these are some of the basic requirements of the catalytic converters. Okay, now moving forward towards the working of the catalytic converter. Here you can see that we have basically two meshes. First one is the reducing element, and here you can also see the second one is this second mesh is of the oxidizing element. Now this is how the catalytic this is how the catalytic converters look like. And here you can see we are basically adding some secondary air whenever it is required. So exhaust gases will be coming from this inlet, and after passing, and you can see here, after passing through this first reducing element, these exhaust gases will consist of unburned hydrocarbons, carbon monoxides, and nitrogen oxides as well. So but after passing through this, here we will have unburned hydrocarbon, we will have carbon monoxide, and instead of having NOx's emission, we will have nitrogen molecules only. And where does this oxygen go? These oxygens are being removed from these nitrogen oxide molecules, because reduction is occurring in these elements. So NOx's emissions are being reduced to form nitrogen and oxygen molecules. So this is what has happened in the reducing element. Now what will happen in the oxidizing element is that we have oxygen molecule from the which we obtained by breaking the nitrogen oxide molecule, and we also have some secondary air as well. And when these unburned hydrocarbons and carbon monoxide and nitrogen and oxygen passes through it, so nitrogen molecules will remain in the form of nitrogen, because the operating temperatures are 250 to 300 degrees Celsius. Therefore nitrogen oxides formation is not occurring in this during this process. And these carbon monoxides will be converted into carbon dioxide, and this carbon dioxide has not only occurred by conversion of the carbon monoxide, but these unburned hydrocarbons are also converted into carbon dioxide and into the water vapors as well. So again, this is not harmful gas, water molecules are not harmful. Carbon dioxide is also less harmful gas as compared to the carbon monoxide and unburned hydrocarbon. Therefore these gases, these products are desirable products, and then these products will be out from the exhaust from this catalytic converter. So this is how the catalytic converters are operating. This is the working principle, this is the working phenomena of the catalytic converters. Now moving forward, all of the thing which I explained here in this diagram are mentioned in these these next two slides. Here you can see that for the reduction catalyst, usually nickel and copper grids are being used, but the best catalyst which we can use is the rhodium. But the use of the rhodium is being limited by the air fuel ratio range, that it operates it has a best performance when the air fuel ratios are from 14.6:1 to from 14.7:1. Again, because of this narrow range, usually rhodium is not being used, but still nowadays rhodium is used quite frequently in the catalytic converters, in the reduction plates, in the reduction catalytic reactions. So therefore for that operation, because of this phenomena in this reducing element, these nitrogen oxides are being removed, are being converted into nitrogen and oxygen molecules. And in the oxidation catalytic reaction, this oxygen molecule and the secondary oxygen which we are providing it will react with this unburned hydrocarbon and carbon monoxide to form carbon dioxides and water vapors. So again, for that purpose, usually platinum and palladium catalysts are being used as a catalyst, and sometimes copper and vanadiums are being used because platinum and palladium are quite expensive. Therefore, sometimes copper, vanadium, iron, nickel, chromium catalysts are also being used, but they are not very good catalysts as compared to the platinum and palladium. So this is how the catalytic converters are operating. Now, what are the major drawbacks? The major drawbacks are that all the reactions which are occurring here are exothermic reactions, and therefore the exhaust which we get are at quite higher temperatures. The conversion of carbon monoxide into the carbon dioxide and conversion of unburned hydrocarbons into the carbon dioxide and water vapors, they are exothermic reactions, as I mentioned earlier in the thermal converters, that a large amount of a heat is being generated, and because of that higher temperatures are being sustained in the thermal converters. So these higher temperatures are not desirable in the catalytic converters. Therefore, the exhaust which we are getting from the out of this catalytic converters are usually at very high temperature, usually at higher temperature than the normal exhaust temperatures. So the next limitation is that these catalysts are quite prone to failure, particularly when we are using leaded fuel. So we do not want to use the lead fuels, and moreover, nowadays lead fuels are also being banned. Therefore, this limitation has already been overcome. And the next disadvantage is that if we are particularly talking about a diesel engine, diesel fuel usually contains sulfur element. So these catalytic converters does not control the emissions of sulfur oxides, and it will increase the emissions of the sulfur trioxide. So instead of controlling it, it is increasing it. Again, sulfur trioxide is the main cause for the formation of the acid rains. As I mentioned in the last video, that because of the excess formation of the sulfur trioxides, acid rains are being produced. So again, it is harmful, but again it is a limitation. But for the SI engines, it is quite useful. In diesel engines, we have this limitation, but again in diesel engines as well, it is being quite frequently used. Alright, now before moving towards the next component, I would like to share a video with you, and it is of the catalytic converter. Now again, here you can see this is our IC engine, and this is the catalytic converter attached to the exhaust manifold. Then we have a resonator and a muffler. Muffler is basically just reducing the noise of the exhaust gases, because these exhaust gases are at coming from the engine at quite high speed and at quite high pressures. So again, mufflers are being used for that purpose. So our main focus is not on the entire exhaust system, but only on the catalytic converter here. So we will focus on that only. So exhaust valve opens here, exhaust gases are coming into the exhaust manifold during the exhaust stroke, and after that, here you can see these exhaust gases are going, and they are not only the exhaust gases, but we have a sound waves as well here, and they are being passed through the catalytic converter here, through the pipe, and inside this catalytic converter, hot gases entering inside this catalytic converter. You can see here it consists of a mixture of carbon monoxide and unburned hydrocarbon and some nitrogen oxides as well. You can see here we have a platinum and rhodium catalytic converter in the reducing element, and platinum and palladium in the oxidizing element. So again, they are being used quite frequently. So these are some the toxic gases. Now again, here you can see that in the reducing element, the oxides of nitrogen are being dissociated, are being broken down into the oxygen and nitrogen molecules only. And again, these oxygen and nitrogen molecules are not harmful. This nitrogen dioxide molecule comes here, nitrogen and oxygen are being produced. Now what will happen in the next phase is, now we have the platinum and palladium catalyst. Now what will happen here is, these are the some of the products which are coming here: nitrogen and oxygen, carbon monoxide and some unburned hydrocarbons. So here you can see, now the carbon monoxide and oxygen will react with each other to form carbon dioxide, which is not as harmful as the carbon monoxide. And not only that, but these unburned hydrocarbons will also react with the oxygen to form water vapors and carbon dioxide as well. So in that case, the nitrogen oxides are converted into nitrogen, and carbon monoxide is converted into carbon dioxide, and unburned hydrocarbons are converted into carbon dioxide and water vapors only. So these three are the only combustion products which remained here: carbon dioxide, nitrogen and water vapors. So now we have a less toxic gases, but again it consists of a sound. So now it will pass through the muffler, and muffler will basically reduce the sound. Muffler consists of a different chamber of different sizes. Now here you can see we have this pipe. This is the first expansion chamber. It will have some drilled holes in it. The exhaust gases will come here and it will strike through this end, and it will come out of these drilled holes, and as a result the sound waves are being reduced. The frequency of these sound waves is being reduced because of these friction phenomena, and then it will enter into the second chamber. And in this second chamber, again because of this collision with the walls, and because of the friction as a result of this collision, these waves will be compressed now, and we will have a lesser sound. And then we have this Helmholtz resonator. The loudest waves of the sound will go into these Helmholtz resonator, and again as a result of this, you can see, as a result of this bouncing, there a bouncing back of the waves will occur, and it will reduce the sound waves. It will compensate the sound waves. Means sound wave is coming from one end, and another sound wave is coming from because of the bouncing back from the other. They will collide, and again as a result these sound waves will cancel each other. Now in the third chamber, again before flowing out from the exhaust, here comes the gases, sound waves, and in this third chamber these noises are being further reduced because of the friction, and then it will go past through this exhaust pipe. Now not only that, the exhaust gases has been reduced to the less harmful, less toxic gases, but noise has also been controlled. So this is how our exhaust gas systems usually operate. So again, I hope you guys must have a better idea regarding how these exhaust gases systems are operating, how these thermal and catalytic converters are operating. Now moving forward towards the third component which are being employed, and that is of the afterburner. Again, as the name suggests, that here an afterburning phenomena is occurring. By the word afterburning, it means that exhaust gases are coming here, and here you can see we have also provided some secondary air in these exhaust gases as well, and we have an additional ignition source in our exhaust, and this ignition source will basically ignite the exhaust gas, will ignite these exhaust gases again into the combustion products, and then these exhaust gases will go out of the in the means of exhaust. It means that again these hydrocarbon and carbon monoxide emissions are now being with the addition of this oxygen molecules, additional oxygen molecules, they are being converted into carbon dioxide and water vapors. So again these emissions can be reduced here, but again we have some we have an additional ignition system here, and again the amount of the energy which is being released during this phenomena is the loss of energy, complete loss of energy. So this is how the afterburners are operating. So the afterburner is located near they are usually located near the exhaust manifold with an intention that there is no fall in the temperature of the exhaust, means there are no temperature less temperatures in the exhaust. The oxidation of hydrocarbon in the afterburner depends upon the temperature of the exhaust and the mixing provided in the afterburner, mixing of the secondary air we are talking about here. And again these systems, these afterburners do not control the NOx emissions. They do not control the NOx emission. So again NOx emissions in these systems are not being controlled. So far we have studied three systems: thermal converters, catalytic converters, and afterburners. All of these systems are controlling the unburned hydrocarbon emissions and converting carbon monoxide into the carbon dioxide, but only catalytic converter is controlling the NOx emission as well, but thermal converter and afterburners are not controlling the NOx emissions. And next we have the exhaust manifold reactor, and again this exhaust manifold reactor is a further increment, further addition, further modification in the afterburners. So the exhaust manifold reactor is further development of the afterburner where the design is changed to minimize the heat losses, and not only to minimize the heat losses but also to ensure that the proper mixing between the exhaust gases and the additional secondary air which is being injected into this exhaust, it provides the sufficient time for the mixing. So not only it is reducing the heat losses, but it is also providing the sufficient time for the mixing of these exhaust gases and the secondary air as well. For that purpose, a positive displacement vane pump which is being driven by the engine is used, and it is inducting the air. It is introducing the air which is coming from the air cleaner, and air passes into the internal and external distributing manifold with tubes feeding a metered amount of a exhaust port of each cylinder, and close the exhaust valve. Means here you can see in this diagram that these exhaust gases are coming into the exhaust manifold, and in this exhaust manifold this additional air is being fed by this air pump, vane pump here. And because of this mixing, this mixing is not only occurring in one cylinder, but it is happening in all the cylinders of the engine. So again, for when we mix those these secondary air with the exhaust gases, and since these exhaust gases are at quite high temperature, this secondary air will convert these unburned hydrocarbon and carbon monoxide emissions into the carbon dioxide and water vapors. So again, it is controlling the unburned hydrocarbon and carbon monoxide emissions. It is not controlling the NOx's emissions again. So so far we have studied now 4 systems, and only catalytic converter is that system which is controlling the NOx's emissions. Therefore, in the modern cars you will see that they are all equipped, in all of these cars we have a catalytic converter installed in it. Next we have the exhaust gas recirculation system, and again, as the name suggests here, what we are doing here is we are basically taking a controlled amount of the exhaust gas and we are recirculating it back into the combustion chamber, and it is one of the most effective way of reducing the NOx's emissions. How? The question is how it basically reducing the NOx's emission. When we recirculate these exhaust gases back into the combustion chamber, they will basically absorb the amount of the heat energy which is being generated during the combustion process, and not only that, they have also diluted the fresh incoming air, which will therefore reducing the maximum flame temperatures. And since the maximum flame temperatures have been reduced now, as a result, no further emissions of the nitrogen oxides will occur. So this is how the exhaust gas recirculation system operates. This is the purpose of using the exhaust gas recirculation system. And not only again, because of this phenomena, we will have some reduction in the thermal efficiencies as well, but again, it is one of the most simplest and the practical method which is being used, which is being employed to reduce the maximum flame temperatures. And that is only by diluting the what we are doing is we are basically diluting the air fuel mixture, and we can dilute it either by using a carbon dioxide gas or maybe some argon gas. Again, these gases are not readily available, we cannot use it. So what is the readily available gas which we can use? And that gas is the exhaust gases which are being produced during the combustion. So we use these exhaust gases for that purpose. So this is what is happening inside the exhaust gas recirculation system. So adding any non-reacting neutral gas to the inlet air fuel mixture reduces the flame temperature and NOx's generation. EGR is done by ducting some of the exhaust gas flow back into the intake system, usually immediately after the throttle, means before the intake manifold, we can say. So again, the figure is I will show you the figure in the next slide. A portion of these exhaust gases is recirculated back to the cylinder intake charge, and it will reduce the quantity of the oxygen available, which was available for the combustion. So as a result, the lesser flame temperatures will occur, and not only that, we will also have some incomplete combustion as well, and we will have the increased unburned hydrocarbon emissions as well. So the exhaust gas recirculation system is taken through an orifice and passed through control valve for regulation of the quantity of the recirculation. By using EGR to reduce NOx emissions, we will have the increased unburned hydrocarbon because lesser oxygen is going, so incomplete combustion will occur. And not only that, but we will also have the lower thermal efficiencies as well. So again, it is simplest and effective way, but it has some drastic effects as well. But again, we will have to overcome those effects. Alright, next here we can see in this diagram that from the exhaust valve, some of the exhaust gases is taken through this recirculation line and pass through this control valve and then into the intake manifold intake line, which is just after the throttle valve, and then from that intake line it will come into the combustion chamber through the intake inlet valve. Therefore the dilution of the fresh air fuel mixture has now occurred. So this is how these exhaust gas recirculation systems are operating. Okay, now again you can see that this was the method which is being an additional device which is being used for controlling the NOx emission, but it has increased the amount of the unburned hydrocarbon emissions. So now I will show you another video regarding the exhaust gas recirculation system now.
In petrol and diesel engines.
So they are being incorporated in they can be used in petrol and diesel engines as well.
Here we can see its basic structure. Exhaust gas is taken directly after the cylinders. Then the EGR valve regulates the subsequent mixing of the exhaust gas with the intake air. This means that less oxygen reaches the cylinder. Less oxygen means a lower combustion temperature.
So again, as you can see from this animation as well, that the exhaust gases is being taken back into the intake manifold with the help of this control valve, and as a result the lesser amount of the oxygen is now going into the combustion chamber. Therefore incomplete combustion will occur and the lesser temperatures, flame temperatures, will be achieved. As a result of incomplete combustion, hydrocarbon emissions have been increased, but as a result of these lesser flame temperatures, NOx emissions have been reduced quite frequently.
This way, nitrogen oxide quantities can be reduced by up to 70%.
Again, nitrogen oxide formation can be reduced by using this method up to the 70%.
And as the higher the temperature, the more harmful nitrogen oxides are produced. In petrol engines, this can also reduce carbon dioxide emissions and fuel consumption. A key component of exhaust gas recirculation is the EGR valve. It meters the quantity of exhaust gas that is returned.
Again, this EGR valve is one of the most important component of this EGR system. it is basically controlling the amount of the exhaust gas which is being recirculated back into the combustion chamber.
EGR valves come in various designs and models, pneumatic or electrical, for petrol or diesel applications, or with connections for cooling. Regulating throttles are used in the intake air system in diesel vehicles. They generate the pressure difference required between the exhaust gas side and intake side to achieve the necessary high exhaust gas recirculation rates.
So again, this was all about this throttling valve. It is basically controlling the amount of the air which is going, and not only that, but it is also allowing the desired amount of the exhaust gas which is needed to be recirculated.
Air mass sensors are required in diesel engines to regulate the exhaust gas recirculation, for example. With their help, the mass of the recirculated exhaust gas is calculated indirectly using the reduction of intake air. Since simple exhaust gas recirculation has no longer been sufficient to fulfill emission standards for some time, EGR coolers are used.
Now again, there is some another, you will not see this EGR coolers in the schematic which I have shared in these slides. Here you can see we do not have any EGR cooler present here. Again, this EGR cooler is basically being employed to overcome the modern requirements of the Euro standard, and it basically cools down the exhaust gas, and since it cools down the exhaust gas, it will therefore it will again reduce the undesirable emissions as well.
Cooled exhaust gas reduces the peak combustion temperature even further. This again significantly reduces the amount of nitrogen oxides. Just like all components in the EGR system, EGR coolers are exposed to the extreme conditions of the aggressive exhaust gas condensate.
So again, as it is mentioned here, that it is reducing the temperature of the exhaust gas which is coming into the cylinder, therefore again we will have a lesser nitrogen oxide emissions.
They must therefore be manufactured from highly corrosion and temperature resistant materials. Many of today's EGR coolers feature an electrical or pneumatic bypass flap. They allow the exhaust gases to be directed past the EGR cooler in the warm-up phase to quickly bring the engine and catalytic converter to operating temperature. This also reduces noise generation, the so-called diesel knock, and the raw emission of hydrocarbons in the warm-up phase. Bypassing is also possible if high exhaust gas temperatures are required, for example in the recovery of the diesel particulate filter. The previous high-pressure exhaust gas research.
So again, it was mentioned here that all of these systems will be intact with each other, they will be connected with each other. Like in catalytic converters, since we require low temperatures, so this EGR cooler will cool it and then it will send it to the catalytic converter. But when we are particularly talking about the diesel particulate traps, we will discuss about the diesel particulate traps in this video, but later in this video. So they usually require some higher temperatures like 700, something around 600 to 700 degrees Celsius. So again, that cooler will provide, if in CI engines, that cooler will basically provide the emissions to that diesel particulate trap at a higher temperatures. Now here you can see that in order to provide the necessary we can say in order to follow the necessary requirements of the Euro 6 standard, not only these EGR systems are being used, and another system is also being employed, which it will be explained here in this video.
Circulation system is no longer sufficient for meeting the limit values as of Euro 6 and Tier 2. An additional low-pressure EGR system is required.
So again, you can see here that we have basically utilized an additional EGR system, which is operating at a quite low pressure.
With this system, the exhaust gas is taken after the particulate filter on the low pressure side and added again before the turbocharger compressor. An exhaust gas flap provides the exhaust gas back pressure required for this. Pierburg is a
So again, before even reaching the turbocharger, it basically has injected some amount of the exhaust gases. So again, it has reduced the NOxes produced in the IC engine with the help of some additional low pressure EGR system.
significant contributor to the current state of the art. The first EGR systems were used in some petrol-driven vehicles as early as the 70s. In the 90s, this technology also began to be used in diesel vehicles.
So I hope all of this is very easy to understand and must have a better visualization with the help of these videos. Now moving towards the last component which are usually being incorporated and which I mentioned earlier, which was mentioned in the video as well, the diesel particulate traps. So the next topic is the next component is the diesel particulate traps. Again, these particulate traps are being employed in only CI engines, and in these CI engines, what happens is that we basically have the soot formation and some solid particulates which are being generated. So for that purpose, we usually have these particulate traps, and they would be trapping these particulates and will not send these particulates directly into the environment from the exhaust of our engine. So they are just like filters, and usually made up of ceramic in the form of a metal wire mesh, and usually it removes 60 to 90% of the particulates which are being generated during the combustion. And so with the passage of time, they will slowly fill up, and then it will restrict the exhaust gas flow. So for that purpose, the traps are being regenerated, and regeneration consists of combusting these particulates in the excess of oxygen. So this is what will happen for the regeneration purpose. And sometimes we basically usually have three types of a regeneration: normal regeneration, dynamic regeneration, and then the service regeneration. So I will explain these regenerations later. So this is how these particulate traps are working. They usually trap it, and then for the regeneration purpose, then when large amount of these particulates have been trapped, the restriction in the flow will occur, and in order to overcome this restriction, these exhaust traps, these particulate traps, are being regenerated. So this carbon soot usually ignites at about 550 to 650 degrees Celsius, while the exhaust of CI engine is at 150 to 350 degrees Celsius. So in order to generate it, usually we require a higher temperatures, and therefore some ignition systems are usually being incorporated for that purpose, which will provide the necessary amount of the energy to combust these particulates during the regeneration. So in some systems, automatic flame igniters are used when the pressure drop across the trap reaches to the predetermined value. When the pressure drop has gone through to the significant values, what will happen that these automatic flame igniters will ignite, and it will basically ignite those particulates which are being trapped in these particulate traps. So if catalyst material is installed in the traps, these temperatures are being reduced from 650 to 350 to 450 again, with the help of the catalyst. So some traps can automatically regenerate by self-igniting it, but sometimes the self-ignition does not occur. So usually there is a system, there is another system, additional system which is being employed, and that is of the automatic flame igniter system. So again I will show you another video regarding the this video is regarding the particulate traps.
Welcome to Automate Fundamentals. Hi, I'm Luke. In this module, I'll take you through the construction and function of a diesel particulate filter. The days of dirty black smoke are rapidly fading due to diesel exhaust technology evolving over the years. Strict emission regulations require diesel engines to become much cleaner. The diesel particulate filter, also known as a DPF, is a filter device fitted to exhaust systems on modern diesel engines. These devices can be fitted before or after the catalytic converter.
Here you can see that these devices can be installed before or even after the catalytic converter.
They require heat to operate correctly. This is why some diesel particulate filters are mounted directly after the turbocharger. The design of the DPF consists of a honeycomb filter monolith and is encased in a metal shell, just like a catalytic converter. Connected to it is a differential pressure sensor with pipes coming out of the inlet and the outlet of the DPF. We'll cover this shortly. Diesel particulate filter materials come in many variants. The most common materials used within a DPF are cordierite wall flow filters or silicon carbide wall flow filters. Other materials can include metal fibre filters, metal fibre flow-through filters and partial filters. Common rail diesel engines fitted with a DPF require a special low ash oil. The purpose of the DPF is to trap the particulates created by all diesel engines, preventing them from entering the atmosphere. These particulates are extremely harmful to the respiratory system. The particulates are trapped by microscopic channels which are within the diesel particulate filter. The particulates, or soot, that attach to the walls of the channels within the DPF are burned off regularly in a process called regeneration. The regeneration prevents the diesel particulate filter from blocking up.
Now as you can see here that these particulates have started to clog these filters, and when we have a large amount of a clogging here, we will have a restriction in the flow of the exhaust gases, which will be indicated in the pressure differential sensor. And when this pressure differential sensor shows the desired shows that amount which we have set in the auto ignition system, that amount of the pressure difference, then this self ignition system will ignite these particulates into the, and then this phenomena is called the regeneration.
Are burned off regularly in a process called regeneration. The regeneration prevents the diesel particulate filter from blocking up. There are three types of regeneration: spontaneous, dynamic and service. Spontaneous regeneration occurs when the DPF reaches 600 degrees Celsius or 1112 degrees Fahrenheit. If a spontaneous regeneration does not occur and the ECU calculates that the DPF has reached its storage capacity, a dynamic regeneration is initiated. Dynamic regeneration is indicated when the DPF light illuminates on the instrument cluster. The vehicle must keep going to complete the regeneration until the light goes out. If the dynamic regeneration is interrupted by the engine being stopped, it will be reinitiated on the next engine run cycle. If the dynamic regeneration is continually interrupted due to a number of short trips, the DPF light will start to flash. A flashing DPF warning will indicate that a service regeneration should be performed. Service regenerations must be instigated using a scan tool. During a service regeneration, extra fuel can be added in the form of post-injection pulses. This increases the exhaust gas temperature, creating extremely hot temperatures of around 600 degrees Celsius or 1112 degrees Fahrenheit to enable the particulates to burn off. If a flashing DPF warning is ignored, the soot accumulation may reach a level where replacing the DPF is the only possible remedy. Once a service regeneration has been performed, the reading from the differential pressure sensor will determine how effective the regeneration has been. Usually, a dynamic regeneration needs to follow a service regeneration. Remember to perform the appropriate drive cycle. If a regeneration isn't possible, the diesel particulate filter must be replaced. Untreated exhaust gases leave the cylinders, carrying the particulates to the DPF. They come into contact with the microscopic channel walls and the soot is trapped. The soot remains in the DPF until the regeneration process is initiated. Now we'll look at the DPF scan tool parameters. I'm looking at the data because I have a flashing DPF light and the soot accumulation is over 100%, as seen here. I'll carry out a service regeneration and we'll take a look at an injector pattern using an oscilloscope. On this scan tool, service regeneration is located in the Special Functions menu. Once the prerequisites are met, the scan tool will initiate a regeneration. The pattern starts off.
So I guess this video has given you an enough idea regarding how these particulate traps are operating, and therefore it has also explained about the normal or spontaneous regeneration. Then we might have some dynamic regeneration, and in the last, the service regeneration. And even after these regenerations, if the particulate trap, if there is a large pressure drop across this particulate trap, then we need to replace it. So this is how these emission control systems are operating. Now moving forward, we have the last topic of this chapter, and it is of the crankcase blow-by. And in these crankcase blow-by, we can understand it simply here that these piston and piston rings, we have some clearance between them, and when these rings worn out, some of the exhaust gases goes into the crankcase, and these exhaust gases may contain these products like carbon dioxide, water vapors, or maybe some carbon monoxides as well. So as a result, these exhaust gases are trapped in these crankcase. So again, from this graph here, we can see that when we have a braided piston and rings, we have a lesser blow-by losses and when the RPMs are increasing, these blow-by losses are also increasing. But again, in bedded piston and rings we have a lesser blow-by losses, but in partially worn rings or badly worn piston and rings, these losses are increasing quite significantly. So it can lead to, so what are the disadvantages of it? It can lead to the high concentration of combustible and air fuel mixture into the crankcase, which could cause an explosion. The air fuel, and not only that, the air fuel mixture, partially burnt and fully burnt vapor fumes will condense and contaminate the engine lubrication oil. So again, lubrication oil, you must have seen it, that when your when the piston rings in your car usually worn out, what will happen, that it will start consuming the lubrication oil as well. The lubrication oil will come into the combustion chamber and the exhaust gases will flow back into the crankcase, into the lubrication oil, which will contaminate the lubrication oil, and it will reduce, it will change the lubrication oil characteristics, and that lubrication oil will not provide the desired amount of a lubrication. So these are some of the disadvantages of the crankcase blow-by. So I think that's all regarding this chapter. I hope you guys must have understood it. In case you have any question regarding these topics, regarding these emission control system, you can just note down your questions. You can ask me the questions in the online session, or maybe in the WhatsApp group of your classroom as well. So okay, that's all for today. Allah Hafiz.